Welcome back, guys. Yeah, so this week, let's just see what was happening. I guess I was debugging. Yeah, I was debugging the issue where the moment I get an interrupt in within my user process, because last week I was dealing the initial issue of when I went into the user process, I was getting false, and that was fixed. So now the user process is able to run like normally. But as you know, I have the interrupt timer interrupt enabled. So after some few milliseconds, my interrupt is being fired, and it's getting handled, and we get into an exception state interrupt handler, and we in this at this point I'm getting an exception. I'm getting in page fault. So I guess this is what we'll be trying to do fix today, because as you can see, I tried to check if the page entries has proper permissions. It does. And right now only thing I wanted to test is that maybe some actual TCR translation control register needs to have some extra bits set, something like that. This is what I wanted to check. Let's see. But the core problem that needs to be solved is that we don't have execution permission, and we get a page faults. And I actually posted this on LinkedIn last week. In general, I just post on my stories whatever I did on the stream. And one person, I guess he's good with home architecture, he commented saying that I should be updating my um, vector exception table base address, because at till this point I completely forgot about that pointer, because we do update it somewhere. I'm not sure where, but as you can see, I think it must be in my start. See, yeah, we set vbar to a table address here. And what is this table? This table is just the location where as soon as interrupts whatever interrupt occurs, it needs to be handled, and we say this particular thing needs to be handled by this handler based on this vector table. And this table starts from this address, that is vbar real1. And I fucking completely forgot about this. And currently, as soon as he stated that in the comment, I knew that probably that could be the potential solution, because in my case, the interrupts are handled properly, but the address just says that it's not executable. I have no idea why, but then because that's why I was trying to set different bit fields and stuff. But this makes sense, because this register holds the actual what is it? Base vector, the base address of the table. So if this table is still 0x8 some address, that means then we are still using the old address. Maybe that's the issue, because I have to think. I'm still not. I still don't completely remember what was happening, but something about it I was trying to do. It was like I'm switching from EL0 to EL1, and because this my entire what is it? My entire code is in some 0x000 range. Even within this EL1, I am currently using TBR0 table, not TBR1 table. So there's two tables. It's EL0 table and EL1 table. And I guess in general, kernel should be starting from FFFF. That way we'll be using the EL1 table. But in my case, because this fucking thing is inside 0x80, whenever I get into the interrupt handler, the current table of BR0 is pointing to user space table, and user space table does not have table entries for this. And even if I add those table entries, for some reason it just does not seem to be working. But the easiest fucking solution is just fix this to update this value as soon as I jump into, because I guess I don't even have to update this here, because we mask every interrupts, so interrupts are not gonna occur at this point. So I believe we could just simply put that here. Hope my explanation was fine. Let me just write it down because it'll be useful for myself. So thing is, my entire kernel is in range 0x800. That means when MMU is started, if I want to access this range, I need table entries in TB 0. Why? Because it's the upper bits zeros, so it will definitely use this table will be used for translation. Okay, so this is fine, and I guess at this, when I start my MMU initially, both my TLB0, TLB and TRB0 and TRB1 both are pointing to the same table, so this just works fine. But when I jump into a user process, I have to update the TBR to 0 to its users to an user specific table, and this table does not have entries for that kernel range. But that should be fine, because within the user process we are not going to access this range. But when the interrupt occurs, we get into EL1, and the interrupt handler code lies within 0x800, so it will automatically try to use the TBR0, which does not have entries for 0x8. That's the issue. So like I was trying to just somehow get around it by adding those permission, adding I was trying to just add those entries, which is really bad and still fails with some permission issues. Someone pointed that I could just update my V bar to point to 0xFFFF. So when I get an interrupt, I won't need that TBR 0 at all. This is what that person just pointed out, and I believe this is the best solution, and this should be the proper solution. I was just trying to get around it by fucking with it, which is not correct. But at least I thought at least I just wanted to confirm if that was the issue, so I wanted to try that out. But even the trying took a lot of time, and it got me nowhere. And I just commented the entire story in that post, and someone just was kind enough to answer, so it's fine. Thank you anyway. And let's try it. But first of all, I don't know if still it will work, but I believe it will work. Because in theory, if the address starts from FFFF, then the table won't be needed. It should work. Let's try. Okay, where are we? I think what we have to do is that as soon as we enable MMU in it, we just update the table. Currently table is here. Currently table is, let's say, 0x8 xxx, and as you know, my MMU init already has the table entries for identity mapping from the virtual space 0x8888 to kernel space 8888. No, from 0xFFFF80000 to physical range 8000. So all I have to do is that update this into to 0xFFFF 1234 and 123. That's it. If I update it to this, it should still be pointing to the same thing, and it should work just fine. But let's see. How do I make the entire thing? Is there any such operation? Maybe I just have to put AND or R. I think if there is any AND operation, I would just have to do AND x0 with what? 0xFFF 000 and 1234 1234. I guess I need to R it. Is there any R operation? That way I'll get these upper bits F, and I'm sure that vector has nothing here, so let's just keep it as 0. And in case if any of those so I think I should AND. Only then if both the values are 1, I'll get 1. If not, I'll just get 0. So I guess, yeah, it's AND. Okay. And instruction in ARM. the fuck? I did not ask that. And instruction on. Okay, it's just and. It's destination. In the register. Yeah, destination register. So yeah, it should be just fine. And it can take an immediate value. Okay, so I have to give this. Let's hope it will work. I don't know, let's just try that. Oh, fuck me. What's the issue? Invalid operand for the instruction. What? I have operand 1 and operand 2. Operand 1 is destination, and destination I have x0. And operand 2 can be a register or immediate value, and it's my immediate value. What the fuck is wrong? Okay, I'll just load it with something and then LGR x1 and then I can just and x0 with x1. That should make sense, at least. Even that doesn't fucking. What the fuck is this arms? Too few operands. What the fuck? What is n? Ah, fucking hell. So it needs 3 operands. X0 and x1. Okay. Okay. Disassemble. Now here. What are we doing? What the fuck is our? After MMU unit. Did those instructions get what is that? It's here. Just take this and the star puts. Let's just update it because we'll be after MMU will be jumping into, or maybe the jump instruction is happening here. So I think it would still be fine. Let's just try this. Okay, let's copy. Let's check what is inside register. Let's see if streaming is still fine. I'm still worried that sometimes simply just does not work. Okay, so this is the address that needs to be written. And what is x1? X1 is this. If we do this operation, if both sides are 1, we should get 1. If not, we get 0. And this is definitely 0, and we need these upper bits to be 1. So I think this operation should work. Let's check info register. What? Info register x1. Why did that AND operation didn't work? Maybe I'm fucking doing something wrong. x0, maybe x0 is taking, it does not take the entire register. It's possible, because let's try R then. I don't know if that's the issue. I'm just going to try. One valid first operand is a register. So R0 is not a register. Wait. 64 bits. General registers. 64-bit is X. Then it should have fucking worked. Maybe I'm just adding this with this. Let's just put x1 here and see what happens. I don't even fucking know how to write a simple AND instruction. That's sad. Still, it's fine. Okay, now x0 turned into this. Maybe do whatever you do to this and store it into this. It's possible. Let's just try this then. Let's try this then. Let's try this and this and this. How come a simple instruction like this is fucking with us? Let's see. Have the register set. Let's do. I never thought I would be trying to fiddle with this. Now x1 is also just this. What the fuck is happening? So definitely the one we put here is the one that is getting updated. Fuck it. We'll just put x0 as 800. This should just be fine, because we are not able to finish the, and I think it's working now. Yeah, it does not seem to be stuck, so it definitely is working. Let's just confirm one thing. We need to somehow check if we are still inside. We are switching between user process 1 and timer interrupt and user process 2. So there's 3 things that needs to be shifted. Okay, so let's go to kmain. Let's check first of all if this works. And I think if we go back to our timer interrupt, we don't want to. Where's my handler? It's here. And if we check what's happening, so we are handling it, and let's just run it once more. Now I believe only timer interrupt is keep on firing. What about coming back to our user process? Why the fuck that didn't happen? Okay, now we started off. We scheduled first one. Probably user process 1 did run, and then timer interrupt occurred, and we should be jumping to this address, but the written address seems to be the issue. Looks like we get a different written address as soon as the first timer is fired, because when the first timer is fired, we jumped into task 1. No, it's fine because it's the user process, so user process address is just something with zeros. This happened within the kernel, that's why the first bits are set, and then this happened in the user process. I think it is working because user process simply does not have anything there. I think it is working. So let's just put a clear this and build it. Disassemble user process 1. Let's try to stop here and run it. We are inside user process 1. Let's continue, and we are still reaching this back here. Let's just try 1. See, we are getting into user process 1, and we are still inside user process 1. Currently the issue would be, why are we not switching to user process 2? How long does user process 1 run? And do we get interrupts if we are inside GDB, moving one step at a time? Let's just delete breakpoints, and now let's run it. and we are inside timer IRQ. So timers are getting fired, and our user process is also working. So let's just write it down. So the final issue would be so after updating the vbar to address 0xFFF, things are working fine. Now the issues is that we are switching between user process 1 and timer interrupt. We should finish like deprive, or how do I put it? We should have at some point run out of time slice and switch to process 2, and this is not happening. Let's check why. Let's just check why. First of all, let's get into our scheduler, because I think the scheduler needs to decide that the process 1 has done its work, and because we are here, we get the timer interrupt and then we call schedule on tick. We get into schedule on tick. Okay, here we are just simply returning, because I guess we are testing out things. If we let it run fully, possibly things might work or things might crash. Let's see what happens. Return address is 0. That's not good. First time when we get into the timer interrupt, after we are inside the user space, the return address is 0. How the fuck? Okay, as soon as the return address, okay, where's my return address? Wait, first of all, have we scheduled both the things? Okay, we have scheduled it because we initted 2 tasks, and when we init something, that also means in the end we are scheduling it, and we don't need this. Let's remove this, because user space should not have kernel entries. And that's fine. Now the thing that needs to be fixed is our scheduler. The scheduler code comes here and it says the next is equal to 0, and we check the currents. I guess let's just bring back all those things and we can debug it. And we never reach this code because we already have these 2 UARTs that did not get. So possibly we returned here, or we returned somewhere in these 2 steps. So let's see. Let's see what happens there. So as soon as get we are done with tick 1, we are in EL1. Done with one tick, we are in EL1. Okay, what does that mean? So that means we reached this point. Let's say done after, before, and we definitely did not reach this, because if we had reached, we would have also gotten this UART. So probably we are returning here. How is that even possible? Did we finish the time slice that quickly? No, this means the time slice still exists. So we are returning the same context, current.context. Maybe this is the issue, because the current context does not seem to have anything. So when we return it, we get 0. It's possible. Yes, time size is still existing and we are in EL1, and so we are returning this, and this value seems to be 0. Why is it 0? That we will never know. First of all, how do we get the return address? Wait. When we first enter it, we have the return address correct. And we say done with tick, and we are exiting EL1. And when the second time we are firing this, even before we enter it, this value is 0. ELR EL1. What is ELR EL1? It's a return address that needs to be the one that we need to go back to. Okay. Now the question is, we are inside user process and we got a timer interrupt. We pause it and we get into this IRQ handler, and this IRQ handler passes this context to us. Let's see how it does that. I think it should be inside. What is vector start being? Where is it? Yes, this is IRQ entry. We save the context. We move SP into x0, we move the stack pointer into x0. Stack pointer should be pointing to the EL1 stack pointer, so that should also be just fine. And what exactly do we save here? Okay, we fixed our restore ret, but did we fix our save context? Let's see. I think the order matters because we are storing it into stack pointer. So we store from the beginning, because stack pointer, we are returning the stack pointer at the end, and in the end we get the one that is in the top. And let's see. Where's my context.c? Oh, as per my context.c, the first one should be the register. So if the stack grows downwards, and let's say I'm somewhere in 0x32, and this is the final register, and I move this value into x0 equal to 0x32, and I'll be considering this value as the x31st, this one, right? Not the one like, do we do any operations after it? We go into vector.c. I guess we do subtract. Yeah, we subtract stack pointer to the size, and then we store we subtract it. So let's say we were somewhere below, and then we store that in the 0th bit, and stack still will be growing below, and first one, second one, and we are returning the end one. And stack grows below, and if I give that as the register, if I give this as the if I return this as the register, I'm just confused because stack grows below and the values are written before it. So if I pass should I pass the stack pointers start or the stack pointers end, or I mean the end of this, that is we are initially decrementing the stack pointer by amounts. And then we return that as the beginning value. I have no fucking clue. I'm just confused. I'll have to draw this fucking thing in the paper to figure out how this layout looks like. Because it's too hard to do in ASCII. Because what is happening is, let's say, oh no, it's too hard. It'll be too hard to draw. So it's like let's say we are somewhere in the stack pointer, and we decrement this stack pointer to some value, to the size. So now the stack pointer is stack pointer has gone below of size this, and stack grows downwards. So decrementing actually means we are incrementing the stack pointer, and then at that point we are storing the at the decremented location we are storing the first register's value till 30th register, and those values are incremented. So we are writing backwards, which is forward. I have no fucking clue. But when we restore it, I don't know, man. First of all, am I even looking at it in the right point of view? Because currently what we are facing is that when the next timer interrupt occurs, we get a written address as 0. That means the context is pointing to 0. So the actual context is the issue. And the context is saved. Context is saved with our macro, and that macro is trying to do this. Currently, we subtract it and then we add it. I need an example to picture it. My fucking freaking mind is not able to picture it. Stupid fucking mind. So let's just write it here. Let's say stack was here, and let's just say, and this was 0x70, and Now we decrement it by 10. That means by 20. That means actually the stack has grown, because stack grows downwards. Okay, then I have to write down below it, or I'll confuse myself even more. Okay, so now the stack pointer is pointing at here at 50 after decrement. This was SP. Now we have a space of 0x20 and the stack pointer is here. Now if we add stack pointer, now the first register is stored at this 0x50 and the second register is stored at 0x50 plus 16. That is a little bit above, and it goes on, and the final register will be stored at probably at 0x70. So the entire thing lies between this. So that looks fine. But my question is, do I have to return 0x70 or 0x50? Because which is the top? And structures are going to consider addresses from ascending order, not descending order. So if I give 70 as the structure's starting point, it's going to read to this. So I guess I have to give the starting address as this 50. If I give the starting address as 50, it will read from 50 towards 70. I think that is what is currently happening, or what's happening here. We decrement it, we write from the decremented value till the 30th value. So that's from 0x50 to 0x70 in our example scenario. And then what happens? And what do we return? We are returning SP, which is still the same, which would be somewhere here, which is the subtracted amount. What is the subtracted amount? Let's go back to our... Yeah, subtracted amount would be 50, and we are returning that. If we return that, a structure will just assume everything after that 50, so it should be fucking fine. And these upper registers are the actual registers, and the ones in the end are the ones that actually have the special registers. So it should be fucking fine. At least if this mental picture was fine, it should be fine. So something else is wrong. I'll have to fucking think. Okay, let's think. We know that when we reach the interrupt handler, we have a context that has ELR value set to 0. So maybe we don't have to assume that the entire context will be 0. Maybe we can print something there and see what's there and what's inside it. Yeah, we can do that. Let's print What can we print? Current state is running. Do we have printf? Let's just copy the fucking printf. And let's fucking print. It's yanked. And I go into the scheduler, paste it here, and then I can just print this. UART printf current context is at L and slice is again an L value. So let's put context it's probably TF and TF that slice. There's no such thing as slice left. I just have to put current dot slice left. Because current is the actual task. Current has a field called context, and that should be updated with the okay. Time slice is still decrementing. Maybe that's why. In that case, let's just bring down this time slice to 10,000. Let's see what happens. So maybe it was working. I don't know. Still the time slice is too big. I can't. Let's just give 100. No, let's just give 10. 10 slices is enough for you. Oh, it is switching. That's amazing. Let's see if we have process 2 here. We have pushed both the things. Now let's see. Now process 1 is running and time slice 3, time slice 2 and time slice 1. Now we push back user process to tail, and now what is there is user process 2, and we set it to running state, and it is running, and it got 10 slices. It's working. It's fucking working. What we can do is just confirm it. Let's just add two break statements. Disassemble user process, I guess, because it's I can just put user process 1 and user process 2 and run it, and I'm inside user process 2 directly. I don't know why. Why am I not breaking inside user process 1? And why the fuck am I not again coming back to... Okay, I'll be inside the while loop. Fine. I get it. Okay, let's just disassemble user process 1. And I guess it will go back to here. So let's just break in this location. So that should always be reached, because we'll be just inside the block. And let's do user process 2, and let's do the same thing here. Now if we continue, we enter user process 2 directly. That's not good. Why am I not inside user process 1? What the fuck is happening? I don't know. Also, we are not switching into interrupt handlers. If we somehow if we add breakpoints, for some reason things are getting fucked up. If we don't add it, it looks like it's working, and it fucking shitted me. So control to BX, yes. Okay, let's just maybe then let's just remove some print messages and see how maybe it's the print messages that are fucking with us. Who knows? Let's try. We don't need to get a message every time interrupt occurs. Let's keep the interrupt occurs message as it is. But we don't need to know the time slice information, because that will be too much data. But we can be done with tick, because that means it only happens after the time slice. So let this be there. Let this message be there. And what other messages can we remove? I think inside came in. What else did we actually run? I'm starting to see a pattern here. We have the initial one, and when we are inside the kernel, we got one timer interrupt. So that's why the return address is starts with 0xFFF. And then we get a timer interrupt. Here the return address is 0. And the return address stays 0 for 10 attempts. And then we say that user process 1 is done. If user process 1 is done, that means we need to restore user process 2, and for user process 2 the return address is fine, so we are reaching user process 2. So I think somewhere we are missing user process 1's return address. Okay. User process 1's return address. What is user process 1's return address? Who will set that value first of all? First of all, generally we are inside the kernel and we get a timer interrupt. We come back to our kernel and we schedule the first process. Where do we schedule it? We schedule the first process because the current task will be the first process. And then we enable interrupts and we jump into first user context. And it says task 1 that context. Wait. I think let's stop here and see what's happening. Disassemble. We have to add FFFs in the front. 1, 2, 3, 4. No. Let's run it. Okay, we are here in the enter into first user process. Let's see what's happening here. We are setting things, we are restoring stuff. And finally we update the stack and we call erit. So at this point we are going to jump from the kernel, which is FFFF, into user process. And it's fucking 0. Wait. Oh, fuck me. Kill Chemo. No. Okay. Let's see. I need to stop there and confirm the EL0 address there. Okay, let's run it and stop here, run it, and this is what we need to check. Let's see what's in our register x1, right? So we have something there for registers x1. We have this address and we SI now. Okay, See, we are storing 0 there. That is why we have fucked up. Okay, okay. Let's think. It must be inside vector.s, and we simply take the zeroth x0 into sp. We are taking x0 into sp. Okay, that's fine. I think that should be fine. Why should that be fine? Because that x1 is actually pointing to task 1's context. Task 1's context is set by us, and task 1's context would be like something like this, and it should have all the values correctly, and it should have the entry to return and restore. We move that to sp, and we decrement sp, and we are trying to read from it. I guess that's the issue, because in that case probably what we have to do is that we have x0 is the top of that structure, and everything within that structure will be after the pointer. So if it's x20 is the x0 value, the value will be in x21, x22, x23. But in our case, because it's sp, what we do is no, we are taking it as incremented values. So sp is the sp. If sp is the start value, we are considering everything after it, not everything before it. Because x0 is taken from sp016. Okay, let's just see it here. 0x 50x sp. sp plus has a lot of stuff. What about sp minus 0x50? That also has wait. Let's just fucking kill it and run it and stop here, run it, and now let's check what's the value of x0, and this is the value of x0. it is looks like it is a user space address. Let's try 50 after that. 50 before it. Now let's try this instruction. sp x sp plus 0x0. $33, $34, $32, $31. Wait, I think I know. The return address should be, return address is not after AX, so let's try before AX. I think this is the return address. This is the return address. Let's check. This is symbol user process 1. It's probably for A4. Or A0, A4 something. There's no fucking A here at all. Maybe that's the issue. Let's double check it. Because that A0 value does not seem to be present in before the stack or after the stack. There is no A. So definitely we are not writing it properly somehow. But then how the fuck did we write it for user process 2 correctly? Let's just see. Context. ELR1. Let's see. What was the value that we set? If we run it and kill it, and if we come back to init, where is it? Here it is one. This is our ELR1. And if we go to decimal to hex, So we are writing it correctly. So when does it actually get fucked? So at this point it is correct. And I think we don't really do much here. Does it fuck up that? It can't fuck up that. So definitely the value is there. If the value is there and if I stop here, I should be able to see that value there. Yeah. Let's just double check that once more. Let's move this. Now we have SP. And what is SP? Info registers SP. And it's this. SP is here. And we're going to take SP plus 272 as our zeroth TRB EL1. Actually, TRB EL1 is a hard-coded path, right? So that should also give us an idea of if things are working fine. Yeah, it should be 0x00F 4 zeros. Let's try that then. If I try this and I try info registers x0, no, x1. No, x1 is pointing to something. X1 is actually pointing to something x1. But if I try SP has this. But in reality, SP should have to 48 minus 0x8 16. So that's the issue. What we are expecting to read there is this. Also, let's just what is 272? 272. Okay, it's 0x10. So plus maybe that's the issue. Even my TRB is wrong. TBR should be 0x08ff0. So let's see if that value is somewhere in my SP. That does not seem to be. Let's just try 100 then. It's nowhere to be found. No, it's not there. It is F00, so we have C00. Is the second register C00? No, it's +6. It must be something bigger than that. So let's try minus. Here do we have that FF somewhere? We have A4. That's a good start. Otherwise, I'm just trying to check if there's somewhere I can find that pattern, because if we can find that pattern, we can come to a conclusion of how far we are miscalculating things, and maybe we can decide something based on it. But it does not seem to be anywhere. I have no clue. How the fuck? We have it here. And the moment we jump into the kernel, it does not seem to be existing. We have some random values there, and when we read that, it's fucked. Anyways, let's just write down what's happening, and then we'll think about it later. So currently we are able to switch between tasks and handler interrupts, but the return address for one of the task is pointing to 0x0, and looks like the context is not passed correctly to the task process 1, Let's review this. Okay, I guess we'll try this out tomorrow then. But in general, at least today we were able to fix the V bar, and just by fixing the V bar value to something that starts with 0xFFFF, we are able to jump into a proper location, and that error goes away and the kernel is running just fine. Now we are able to switch between tasks and between interrupts, and the interrupt is scheduled and the scheduler is switching tasks based on the proper slice. So those parts are working fine. Only thing that's not working is that my user process 0 has to have a ELR value, because that value is the actual one that we jump into, and that value is pointing to 0. I have no fucking clue why. Looks like the context that we are passing, the address does not have anything there. At least it has some data, but those data does not correlate with what we assign to it. So maybe it's we placed it somewhere and we are pointing to something else. Maybe that's one possible issue, or maybe we are pointing to something and we are just calculating the address not properly. I don't know. Let's just try this out tomorrow. But in general, things are going just fine.